a set of 4 terms? Well, just like we talked about yesterday, you always want to start by looking to see if there's a greatest common factor. Now, in this first example, there is not a greatest common factor. So we're going to skip that step, and we're going to go to the next step, which is to group up the first 2 terms and the last 2 terms. Now, you want to be very careful when you do this when you're using your parentheses. Notice how I have this plus on the inside of that parentheses. You want to make sure that happens. You don't want to see things like, I don't want to see things like this or like this. It's when you do stuff like that that's going to cause problems with maybe getting the wrong answers. So we group up the first 2 terms and the last 2 terms. Now in these first 2 terms, you're going to look to see, well, what's the greatest common factor between these 2? Well, between the 2 and the 5, there isn't any, but between the a cubed and a squared, there is. It's a squared. So I'm going to factor out an a squared. Now when I do that from the first term, 2a cubed, when I take away from that the a squared, I'm left with just a 2a. For the 5a squared, when I factor out an a squared from that, I'm left with just the 5. Remember, we can always double check by distributing this a squared through. And when you do that, you still end up with 2a cubed plus 5a squared. But now let's look at the next set of terms here. We want to look for a greatest common factor between these 2, but the way we set it up, you want to be very careful. So I see that I have I can factor out a 3. Each of these have a 3 as their common factor. But it's going to be a positive 3, so I want to write that as plus 3. That plus is very important. You'll see why in a minute. So now 6 divided by 3 is 2, so that'd be 2a. 15 divided by 3 is 5, so that would be 5. Now, if you notice between this part and this part, between these 2 parts, they have a 2a plus 5 in common. So we're going to factor out a 2a plus 5. Now, when I factor out a 2a plus 5 from this first part, I'm left with an a squared. When I go to the second part and I factor out a 2a plus 5, I'm left with a plus 3. So this would be your final answer. Let's look at another one so you can see what's going on here. So if you're a little confused, don't worry. When you look at some of these, they look intimidating at first, but believe me, just take it step by step and you'll see that it's not as hard as it has to be. So here we have, again, you want to look to see before you get started with the grouping, you want to look to see if there's a greatest common factor. So here I have an a and a y, here I have an a, but beyond that we don't have any other a's. And the last 3 terms have a 5 as a common factor, but the first one doesn't. So there's nothing I can factor out of here. That's why I just start right away with grouping up our first 2 and our last 2. Remember that this parentheses, you want to be careful with placing that. So that way this minus is still attached to the 5. You don't want to break that up. Okay, so with these first 2 terms, the only thing I can factor out of here is an a. That leaves me with, oops. When I do that, that leaves me with just the y. When I factor out an a from the first term, when I factor out an a from the second term, I'm left with a negative 5x squared. Now I'm going to go to the next 2 terms. Now remember when we were using the Xbox method, just to give us a visual. Remember if this number here was negative, remember the number that we factor out would be a negative as well, if this first one was a negative. The same thing is true for our parentheses here. If the first thing that we look at is a negative, we want to factor out a negative. Because now when I look at between the 5 and the 25, they have a 5 in common. Between the variables, they have a b in common. So I want to factor out a negative 5b. So now when I take negative 5 divided by negative 5, that's 1, a positive 1. Factored the b out, so I'm left with just 1y, or just y. 25 divided by negative 5 is a negative 5. And then the b, we factored that out, and we're left with the x squared. So now I want to look at this first part and the second part. The first part, that term there has y minus 5x squared, so does the other one, has a y minus 5x squared, so that's what we're going to factor out. I'm going to factor that chunk out. When I factor that chunk out of the first term, I'm left with an a. When I factor it out from the second term, I'm left with a negative 5b. And there's nothing more to do with that one, so that's your answer. Now you might say, well, why is it that when you took out the y minus 5x squared, you only took one of them out? Remember, we're factoring out what they have in common between those 2 sets. It's almost like here at the beginning, we factored out an a, We just factored out one a to represent the two a's from those terms that they had in common. So the same thing is true here. Looking at these two sets, I'm factoring out one y minus 5x squared to represent the 2. So when I factor out the y minus 5x squared from the first term, I'm left with a. When I factor out y minus 5x squared from the second term, I'm left with minus 5b. Let's look at this last example. So again, the way you want to start these out is look for a greatest common factor. This one, as opposed to the other two, does have a greatest common factor, which if you see it, it would be 5. The variables, they don't have a common factor there, but it'd just be a 5 that we factor out of here. Now, I'm going to approach this one from two different ways. One is, why does it keep doing that? One is if we remember to factor out a GCF, and another time we'll also do it again if we didn't factor out the GCF. So when I factor 5 out from this, by the way, too, when we factor these out, I'm going to, instead of put parentheses, I'm going to use brackets. Because the reason why is because when we use a bracket, it's more long-term than a parentheses. Like a parentheses you might use just for maybe a step or two. But it implies that maybe you're going to end up multiplying or distributing, where this 5, we want to set this apart till the very end. This 5 is going to stick around. It's going to be part of our final answer. So that's why we use the bracket, just to keep it separate now from the rest of the problem. But we do divide everything by 5 here. So this will be 8ab plus 30 divided by 5 is 6. So that'll be 6a. Then it'll be minus, and 100 divided by 5 is 20. So it'll be minus 20b. And then it'll be minus, and 75 divided by 5 is 15. Whoops. So now we see from what we just factored, the 5 out, we don't have any greatest common factors there, so now I can break this up into two pieces. So again, this 5 stays outside the bracket. Now from those first two terms, we're going to factor out a 2 and an a, leaving us with 4b plus 3. From those last two terms, again, it starts with a negative, so I'm going to take out a negative. It looks like they both have a 5 in common, so I'm going to take out a negative 5. So negative 20 divided by negative 5 is a positive 4. Then we have the b. And a negative 15 divided by negative 5 is a positive 3. And again, we're going to look at these as two separate terms, basically, and to figure out what they have in common. So they both have a 4b plus 3. And we're left with a 2a from that first term and a minus 5 from the second term. There's no need for those brackets anymore because at this point now I am done and this is my final answer. Now let's say we forgot to factor out the GCF at the beginning. And let's see how we can get the same answer that we got here without factoring out a GCF. So let's look at what we would do here. We would start out by just grouping up the first two and the last two terms. Now from these first two terms you can see that I'd want to factor out a 10 and an a. Now here's where it gets tricky. So I'm going to factor out a negative. Now I want to find the greatest common factor between 100 and 75. There's a couple ways to look at it. One is I want to make sure that in parentheses I end up with 4b plus 3. So I know I'm going to divide something by 100, and I want to get 4 as my answer. So to figure out what that would be, if I take 100 divided by 4, I get 25. So what that means is if I took 25, 100 divided by 25, I'd get 4 as my answer. So negative 100 divided by negative 25 gives me a positive 4 as my answer, so I'd have 4b. But now watch what happens. Negative 75 divided by negative 25 is a positive 3, which is what we want. Now let's say if I didn't do the 25. Let's say if I'd accidentally done just minus 5. Well, when I do that, I'd end up with 20b minus 15. And I'd recognize that, oh, wait a minute here, I could still factor something out. Between the 20 and the 15, I can still factor out a 5. So from there, we'd factor out another 5. So now instead of negative 5, we'd have negative 25 out here. And now when I take out a 5 from the 20, we'd be left with 4b. Take away 5 from the 15, and we'd be left with, that would have been a positive here. positive 3. So either way, you would still get the same answer, just a little bit longer. That's why it's easier just to look for the greatest common factor at the beginning. So again, the way that we got that is I knew that my answer here, I wanted to have a 4. So 100 divided by 4 gives me the 25 that I wanted to factor out. Okay, so now between the 4b plus 3 and the negative, or between the first term, the 10a plus 4 times 4b plus 3, and the negative 25 times the 4b plus 3, they both have a 4b plus 3 in common. But I'm left with 10a minus 25. Now remember yesterday we talked about how we always want to look before we say we're finished and see if there's anything that can be factored out. With the 4b plus 3, there's nothing I can factor out of there. But with the 10a and the 25, I can factor out a 5 from there. Now I'm going to put that 5 in front, even though it doesn't apply to the 4b plus 3 right now, because we're taking it from the 10a and the 25. So 10 divided by 5 would be 2a, and then negative 25 divided by 5 would be negative 5. So my answer would be 5 times 4b plus 3 times 2a minus 5, which if you notice is the same as what we had before. But to me, it seems a lot less complicated if you always look for a GCF first, because then you're going to be dealing with smaller numbers, and it's going to be a little bit more manageable. So if you haven't done so already, print out your assignment, and we're going to look at a couple of them. We're going to look at number 1 and number 5 here, because we won't do the whole thing here, but I just want to get you set up, because these are kind of unique. So again, with number 1, I can't factor out a greatest common factor here. So I'm going to start by grouping together the first 2 and last 2. Now from this first 2 terms, I can factor out a 3. 3a squared, I'm sorry. When I do that, a cubed divided by a squared leaves, when I factor that out, I'm left with an a. And 12 divided by 3 is 4. And negative 9 divided by 3, well, that's 3. And the a squared we factored out. Now, if you look at the next set of parentheses, that's what we want it to stay the same. We don't want it to change. And you also notice that, well, between the 4 and the 3, there is nothing that we can factor out. So we don't just leave it blank. We need to factor something out. But remember, the one number that's a factor of every number is going to be 1. So I can factor out a 1, and it's going to be a positive 1. So as a result, I'm left with 4a minus 3. So now you can see what you should factor out or how to get your final answer. So I'll let you guys figure that out on your own for number 1. But that's a good way to get started, or at least you got started there. Well, now let's skip down to number 5. Number 5, that's also a unique situation, where here I'm going to factor out, because there's no greatest common factor, so I'm going to start by factoring out an m squared. Now when I do that, I'm left with m for my first term. Now some people say, well, I factored out the m squared from the second term, so there's nothing left over, so this is my answer. Well, that would be wrong, because if I distributed the m squared through, we don't get m cubed minus m squared. I just get m cubed. So remember, when I factor something out, if there's nothing left, there's at least a 1 left over. So m squared divided by m squared essentially is 1, so it would be a negative 1 that would be left over. Because now if I distribute this through, sure enough, I get m cubed minus m squared. Same thing with the next set. Here I see that I can factor out a 2. It would be a positive 2, leaving me with, well, 2 divided by 2 is 1, so 1m. And negative 2 divided by 2 would be a negative 1. And you should be able to see what you need to factor from these two terms now. So I'll stop there with that one. So hopefully you have an idea of how to factor when you're dealing with 4 terms, but just like we said at the beginning, always make sure you look for a GCF first, because if it is possible, that's going to make your factoring all that much more easier. So with that, good luck on your assignment.